right, so now we're going to look at a hypothesis test all the way from beginning to end, and we're going to set it up as a 5-step process. So this question, data suggests that 61% of workers at a large company invested in 401ks 10 years ago. Since then, the company has adopted an auto-enrollment plan, which means employees are automatically enrolled and actively have to opt out if they do not want to join. This tends to be really effective, by the way. If you're interested in behavioral economics stuff at all, there's a book called Nudge that has a ton about this, but I won't get too off track. A recent survey of 100 randomly selected employees found that 83 invest in 401ks. Does this provide sufficient evidence that the proportion has increased in the last 10 years? Okay, so we're going to do this as a 5-step process. We'll start by writing out our hypotheses. Okay, so the first one, we'll write the null hypothesis, and we're going to write it in terms of the population proportion, right? Because we don't need a hypothesis test to tell us what p hat is. We can just go ahead and calculate it directly. So p hat is the sample proportion, and it says here that 83 out of 100 invest. So we know right away p hat is 0.83. But we want to know whether the whole company, whether things have really improved at the whole company or if this was just sort of a lucky sample. Okay, so remember the null hypothesis is going to be the boring one that sort of says nothing has changed. So if nothing has changed, then the population proportion who invest is still 61%, 0.61. The alternative is what we're trying to prove. So here we have to be kind of careful with how we read the question. So does this provide sufficient evidence that the proportion has increased in the last 10 years? So you can see that's what we're trying to prove. So we'll write our alternative is that p is greater than 0.61. Before we get too far, we need to check our conditions. These tell us whether or not it's appropriate to conduct a z-test. So the first one is just that we have a random sample. If we want to generalize to the population, we need a random sample. So again, we can read carefully and we can see that these were randomly selected employees. So we're good on that. The second one is we need to make sure that our sample size is large enough. We're going to take n times p. So n, remember, is our sample size, so that's 100. P, we're going to get that from the null hypothesis, so multiply that by 0.61, and then check to make sure that it's at least 10. So we're good there. We also want to check in 1 minus p. So here that would be 100 times, can I do math, 0.39? 39, also bigger than 10, so our sample size is big enough to continue. Okay. The third step is to calculate our test statistic. So that's the standardized statistic, gives us a little more information than p hat on its own. So this is going to be a z statistic, and you take your actual sample value p hat, and you subtract the value from the null hypothesis, and people write it as a p with a little 0 to show it comes from the null hypothesis. And then you're going to divide by the standard error. So the standard error, the formula that we saw for this, is the square root of p times 1 minus p, and all of that over n. So all that's under the square root. Okay, so now we just have to plug in. So we said our sample proportion p hat, that's 0.83, minus the value from the null hypothesis, that's 0.61. And then we're also going to plug in 0.61 into our formula for standard error. So it's going to be 0.61. 1 minus that is 0.39. And then our sample size is 100. So we're going to end up with a z-statistic of 4.51. Okay, and we saw last time how to interpret that. So this is telling us about our sample proportion. Our sample proportion, p hat, is 0.83. That's telling us how many standard errors it is from the null. So this is 4.51 standard errors, above what we would have expected. So above what we would have expected if the null were true. So we're saying if nothing had really changed, how unusual would it be to get a p-hat like ours? Okay, so that's our test statistic. The next step is to calculate a p-value. We can calculate a p-value if we've got a z-statistic already that is actually really nice. We're going to work with a normal distribution, and it's going to have a mean of 0 and a standard deviation of 1. So it just goes 1, 2, 3, negative 1, 2, 3. And that's what we're going to use to calculate our p-value. So before I actually do that, before I do the calculations, I wanted to give you a chance to sort of process what we've done so far and also to make some predictions for what comes next. So pause the video and ask yourself, what does it mean when the z-statistic is large? And do you predict the p-value will be large or small? Okay, so now that you've made your predictions, let's finish up this problem. So if you remember what we're actually looking at in this picture, this is showing us all the different values of the z-statistic that we could get, and this is assuming that the null hypothesis is true. So if nothing had really changed, the null hypothesis is true, these are the z-statistics that we would expect to see. Okay, it goes basically out to 3. Well, you can see 4.51, it's way off the chart over here. Right, so 4.51 doesn't seem to be consistent with the null hypothesis. So if we think about our z-statistic, our z.4.51 would almost never occur if the null hypothesis were true. It would almost never occur if the null hypothesis were true. So in this one, we really don't even have to do the calculation because we know how the normal distribution works. We know that our p-value is going to be essentially 0 here. But if we want to calculate it really quick, we can go to Add-ins, Teaching Modules, Distribution Calculator, and it automatically pulls up the normal distribution with a mean of 0 and a standard deviation of 1. That's what we want. We put our test statistic in here, so 4.51, that goes in the input value box. And then because our alternative hypothesis was greater than, we're going to pick greater than as our probability option. And you can see here that the p-value is very small. Specifically, it's less than 0.0001. Okay, so the fifth step is our conclusion. We always want to write our conclusion in context to make sure it would be clear, even if somebody didn't really understand statistics. So to make our conclusion, first of all, we just need to think about the size of our p-value. And a lot of times we compare it to an alpha, but honestly here, that's not really that important because it's so small that this is going to be smaller than any reasonable alpha level. You know, we'll usually see alphas of like 0.1, 0.05, 0.01. This p-value is smaller than any of that. So because our p-value is so small, we're going to reject the null hypothesis, right? We reject when the p-value is small. And in context, we're going to conclude the alternative. So we have enough evidence in this case. We have enough evidence to conclude HA. And we don't want to just say p greater than 0.61 because that's not really very easy for people to read. So we're going to say to conclude that the proportion who invest in 401ks, because that's what we were interested in here, the proportion who invest in 401ks has increased. So we had enough evidence to rule out the null hypothesis and go ahead and conclude the alternative.